This research paper, titled CoLoTa, a dataset for entity-based common-sense reasoning over long-tail knowledge, is authored by Armin Torigi from the University of Toronto, Willis Guo from Carnegie Mellon University, and Scott Sanner from the University of Toronto. It explores the limitations of large language models, or LLMs, when dealing with common-sense reasoning involving obscure or long-tail entities, those that aren't commonly discussed or well represented in typical training data. The paper begins by highlighting the transformative impact of LLMs in artificial intelligence. These models, like OpenAI's o1 or GPT-4o, excel at encoding vast amounts of factual and common-sense knowledge, enabling them to perform well on tasks that require reasoning. However, they still face significant challenges, particularly with hallucinations, where they generate incorrect or fabricated information, and reasoning errors. This is especially evident in high-stakes applications, such as medical diagnosis or legal advice, where accuracy is crucial. The authors point out that even top-tier LLMs struggle with common-sense reasoning over long-tail entities. These are entities that are not mainstream, like lesser-known historical figures, rare objects, or niche concepts that don't appear frequently in online data or training sets. For instance, while LLMs can handle questions about well-known figures like Barack Obama, they falter when the queries involve more obscure subjects, leading to high rates of errors. To address this gap, the paper introduces a new dataset called CoLoTa, which stands for Common Sense Reasoning over Long-Tail Entities. This dataset contains 3,300 queries derived from question answering and claim verification tasks. It covers a wide variety of common-sense reasoning skills, such as understanding relationships, making inferences, and verifying facts based on implicit knowledge. An important aspect of CoLoTa is its connection to knowledge graph question answering, or KGQA. The knowledge needed to answer these queries is available in the Wikidata knowledge graph, which is a large, open database of structured information. Unlike existing KGQA benchmarks that focus mainly on straightforward fact-based questions, CoLoTa goes further by requiring true common-sense reasoning. For example, a query might ask something like whether two obscure historical events could have overlapped, demanding not just factual recall but logical inference. The authors conducted experiments using strong LLM-based KGQA methodologies to test how well these models perform on CoLoTa. The results were striking, showing that even advanced systems have a severe inability to handle queries that involve common-sense reasoning over long-tail entities. This highlights a critical weakness in current AI technologies. In terms of categorization, the paper falls under CCS concepts in information systems, specifically language models and question answering, as well as computing methodologies related to knowledge representation and reasoning. Key keywords include large language models, common sense reasoning, knowledge graphs, and question answering. The ACM reference format provided indicates that this work was presented at the 48th International ACM Siggier Conference on Research and Development in Information Retrieval in 2025, in Padua, Italy. It's an 11-page paper with the DOI for citation. Delving deeper into the introduction, the paper emphasizes how LLMs have revolutionized AI by enabling entity-based common-sense reasoning. This means reasoning about specific real-world elements like people, places, or objects. For example, an LLM might use common sense to determine if two presidents could have met based on their terms in office. However, the persistent issues of hallucinations and errors undermine their reliability, particularly with unfamiliar entities. The authors note that existing benchmarks for entity-based common-sense reasoning, such as Strategy QA and CREEK, primarily test on popular entities. These benchmarks work well because LLMs have been trained on abundant data about figures like Obama or Mitterrand. But this doesn't reflect real-world scenarios where questions might involve long-tail knowledge, which is underrepresented in training data. CoLoTa is positioned as a novel benchmark to evaluate two main things. First, the common-sense reasoning capabilities of LLMs and their robustness against hallucinations when dealing with long-tail entities. And second, the performance of KGQA methods in handling common-sense tasks beyond simple fact retrieval. In their experiments, the authors tested prominent LLMs like OpenAI o1, GPT-4o, Gemini 1.5 Flash, and LLAM A 3.3. They found that these models exhibit high error rates on CoLoTa queries, often failing to make accurate inferences or generating plausible but incorrect responses. This underscores the need for better training techniques, perhaps incorporating more diverse data or specialized fine-tuning for common sense reasoning. The paper also touches on the broader implications for AI development. By providing CoLoTa as an open resource, it encourages researchers to improve LLMs and KGQA systems, potentially leading to more reliable AI in applications like chatbots, search engines, or decision support tools. The dataset's design ensures it can be used for various tasks, making it a versatile tool for the community. Overall, CoLoTa represents a significant step forward in benchmarking AI's ability to handle complex, real-world reasoning, pushing the field to address the challenges of long-tail knowledge and enhance the trustworthiness of language models.